Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics, and specifically the topic of transformations. We'll be looking at the past paper solutions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help you by creating other videos in any other areas that you are struggling with. Don't forget to look at the description down below where we have outlined the order we suggest that you go through all the videos for the entire CSEC Maths syllabus so you can get a better grasp of the entire subject area. Let's recall the 10 major topics in CSEC Mathematics. And in this video, we'll be looking at topic number 8, Geometry and Trigonometry. This topic can be split into Geometry or Trigonometry, and Geometry itself can be subdivided further into 4 parts: Circle Geometry, Parallel Lines or Unknown Angles, Geometric Construction, and Transformation, which is what this video is about. This topic number 8 is tested for 8 questions out of the 60 in paper 1 multiple choice and for 21 marks out of the 100 in paper 2. May 2019, number 3B, triangle ABC with vertices A, 1, 1, B, 1, 4, and C, 3, 1 is shown on the diagram below. Let's recall that when we're given these coordinates, the first value is the x coordinate and the second will be the y coordinate. Triangle ABC is mapped onto triangle LMN by a reflection in the x-axis, followed by a reflection in the y-axis. Part 1. On the diagram, draw and label triangle LMN. So what we need to do is draw the mirror line for the first reflection. So let's bring up the mirror line along the horizontal axis, which we have in blue, and let's reflect each point along that line. So for the point A, it's 1 unit above the horizontal axis. So when it's reflected, it's 1 unit below the horizontal axis. B is 4 units above the horizontal axis, so when it's reflected, it ends up 4 units below. And C is 1 unit above, and it will be reflected, so it'll end up 1 unit below. So we can now connect the dots with a triangle that's in pink. So that's the first reflection. Now we need to reflect it along the y-axis. So let's bring up the y-axis as a dotted line in green and reflect each of those points. The point A, which is reflected down, will now be reflected to the left. It's 1 unit away from the y-axis on the right-hand side. So once reflected, it will end up 1 unit on the left-hand side. And that will be L. And then B, which was 4 units below the x-axis when it was reflected. Now that it's been reflected for a second time, it's 1 unit away from the y-axis. So it'll go 1 unit away on the left-hand side, which will be M. And similarly, N is 3 units away from the y-axis, so when it's reflected, it'll be 3 units away on the left-hand side. And now we can connect those dots with a blue triangle. So we've completed the double reflection. Part 2. Describe fully a single transformation that maps triangle ABC onto triangle LMN. So the original triangle ABC, how can we make one transformation for it to end up at the LMN, the blue triangle? So let's look at it. Let's recall that there are 4 types of transformations generally that we use. One is a translation or a slide, and we can see that this doesn't slide here because if it slides, the orientation remains the same, meaning that the general direction in which it's pointing will remain the same, and it doesn't. The second type will be a reflection, and no one single reflection will move ABC onto LMN. The third one is an enlargement, and you can see that this doesn't happen here either. And the last one will be a rotation. Let's bring up the triangle ABC and let's rotate it about the center, about O, the origin, 180 degrees, and it ends up at LMN. As such, we have a rotation, we have the center, the angle will be 180 degrees in the clockwise direction or in the counterclockwise direction. It'll end up in the same spot. Part 3. State the 2x2 matrix for the transformation that maps triangle ABC onto triangle LMN. And that's simply minus 1, 0, 0, minus 1. And that's enough for the solution. But let's go through it. If we look at all the values, the x and y coordinates of ABC, and compare them to LMN, what is happening is that each of the x and y coordinates becomes the negative value of it. So if we take minus 1, 0, 0, minus 1 and multiply by xy using matrix multiplication, then rows by columns, so we'll have minus 1 by x plus 0 by y on top, and 0 by x plus minus 1 by y, and we have the different colors to make it easier for you to see the multiplication. So the top works out to be minus x plus 0, and the lower point becomes 0 plus minus y, so it simplifies to minus x minus y. So it is the changing of the values from xy to its negative values, minus x minus y, by using this 2x2 matrix. May 2021, number 3b. The diagram below shows 3 triangles x, y, and z on a square grid. Part 1. Triangle x is mapped onto triangle y by reflection. State the equation of the mirror line. And we can see that for the mirror line, they will be equidistant, meaning they will have the same distance, both triangles, from that line. So if we look at it, we can see that they are 2 units away from the x-axis above and below it. So that means the x-axis is our mirror line, which can be written as y is equal to 0. Part 2. Describe fully the transformation which maps triangle x onto triangle z. If we look at triangle x and we want to move it onto triangle z, we can see that that is a rotation. So let's bring it up in blue. And as it rotates, the center of rotation will be 0, 0. And what's the angle? You can see there that we have that orange line to show where it was originally and where it has moved to, and the angle is 90 degrees. So it has moved 90 degrees in an anti-clockwise or counterclockwise direction. Part 3. On the diagram, translate triangle y using the vector minus 7, 1. Label this triangle V. So minus 7, 1, the column vector, means that we're moving 7 units to the left, and we see that with the purple line, and then 1 unit up. So we can translate the whole triangle where that is the base point and it comes across and label it V. Last part of the question, part 4. On the diagram, enlarge triangle X, that's the first triangle we have in the first quadrant, about the center C, 0, 0, and scale factor of a half. Label this image W. So if we start at the C, 0, 0, the center, and we draw a line outwards using a scale factor of a half, it means that the length of that line is now half of it. So instead of it being 4, 4 units to the right, and then 4 units up, it will now be half of that, which will be 2 units to the right and 2 units up. So let's bring up that point. So the top of the triangle, the highest vertex, now moves to this new point. And let's look at the point on the right-hand side. Let's draw a line through it from C. And we can see that's 6 units to the right and 2 units up. So half of that will be half of 6, which is 3 units to the right and 1 unit up. So we've gotten 2 points. And for the third point, let's draw that in a dark red line to see it clearly along the y-axis. From C going through that point is actually 2 units upwards. So half of that will be 1 unit upwards. So let's bring up that point. So the entire triangle which we had Originally, the triangle in X has now shrunk to half the size with these 3 new points. So let's connect it using a yellow triangle. So we've completed the question. May 2022, number 3. The diagram below shows 4 shapes. P, which we have as shaded, Q, the shape to the right of it, R, the shape to the left of it, and S, the shape below, on a square grid. Part A. Describe fully the single transformation that maps shape P onto Part 1. Map shape P onto shape Q. So let's bring up shape P and let's see how it moves until it ends up at Q. So therefore that is clearly a rotation. And if it rotates, the center of rotation, we can bring that up with a little X on it to show that point, will be 7, 7. And how much did it turn? 180 degrees in either the clockwise or anti-clockwise direction will still give us the same result. Part 2. Describe how shape P moves onto shape R. So let's look back at shape P, which is shaded, and shape R is to its left, and we can clearly see that that is a reflection. And when we're describing reflection, we need to know where the line of symmetry or the mirror line is located. In order to find the line of symmetry, let's look at the right vertex of shape R, which is at -1 along the x-axis, and let's look at the left vertex of shape P, which is at 3. So the distance between these two vertices is 4 units. So that means the line of symmetry will be halfway between those 4 units, so it'll be 2 units on the left and right of it. So we can see that the line of symmetry, we'll bring it up as a green line, and that way we can easily tell that there's a reflection from P onto R, and that line of symmetry is the line x is equal to 1. And for part 3, describe fully the single transformation that maps shape P onto shape S. So if we look at shape P again, that's our original shape, which is shaded, and shape S, which is below but larger, it means that going from P to S, there is an enlargement. And if there's an enlargement, we want to find the center of enlargement. And how do we do that? Well, we can just connect the corners or vertices by straight lines. So let's look at the right-hand side of P. That's a vertical line. And for S, it's the same. So if we draw a red line going through it, that means the center of enlargement lies somewhere along that line. And similarly, let's pick another point on P and S. And let's draw a line through it. And where these two lines intersect, that is our center of enlargement, which is 7 for the x value and 11 for the y value. And we want to know the scale factor when we're dealing with enlargement. How much bigger or smaller did it get? And if we look at the center of enlargement, which is 7, 11, and we're going downwards through P, it'll carry us to S. They're all going in the same direction, so the scale factor is positive. And it got larger, so let's figure out how much bigger it got. Let's measure the base of P, which is 1, 2, 3, 4 units, and the base of S, let's count it from -1 to 7, so that's 8 units. So it went from 4 until 8, so the scale factor is 2, because it got twice as large. And part B, the last part of the question, on the grid provided, draw the image of shape P after a translation by the vector -2, 3. Label this image T. So shape P is our original image again, which is shaded, and we want to translate it. Means that we want to slide the image by the column vector notation -2, 3, which means 2 units to the left and 3 units up. So let's take the top right side point or vertex of the shape P. Let's move it 2 units to the left. And let's go upwards 3 units. Let's bring it up and slide it across, and that's our new image T. So we've completed the question. We have now come to the end of CSEC past paper questions in the topic of transformations. In the first video in this series, we looked at past paper questions from 2009 until 2013. In our second video, we looked at 2014 until 2018. And in this video, from 2019 until the present. Don't forget to look at the description down below, where we've outlined the entire syllabus for you.